Variable rate problems involve a thing that is affected by more than one rate at different times. The best way to look at the difference between constant and variable rates is to look at a variable problem. In this example, the temptation is to think that the average of 70 and 30 is 50, so the answer is 50 miles per hour. Wrong. The reality is that the train is traveling the same distance at 70 miles an hour as it is at 30 miles an hour. So it travels at 70 miles an hour for a much shorter amount of time than at 30 miles an hour. You will notice that we want to find the average speed, and given the equation average speed equals total distance divided by total time, it seems like we don't have enough information to solve this problem, because they don't give us total distance or the total time. It turns out we don't need those values to solve this problem. We can use a variable to represent distance, and with the same tricks we learned to solve simple rate problems, we can use algebra to arrive at the average speed. First, we notice that the train went half the distance at each speed. So if we use the letter d to represent the total distance, the train went d over 2 miles at 70 miles an hour and d over 2 at 30 miles per hour. Let's use a trick from treating rates as conversion factors and cancel out the miles units on d by multiplying by 1 over our speeds. We do the same process for each speed value, and both are shown on the slide separated by a line down the middle. So after we cancel out our miles values, we have two time values. Time 1, which is the first half of the trip, is equal to d over 140 hours, and time 2 is d over 60 hours. That number might seem odd because we're only halfway through the procedure. Don't let the units throw you off if they don't seem to make sense during the problem. Just be sure to follow the rules of algebra in dealing with units and make sure your final answer makes sense. To find the total time, we add time 1 and time 2. Remember, in adding fractions, we need to find a common multiple of each so that we can add two fractions with the same denominator. This gives us a total time equals d over 42 hours. Now we are ready to solve the problem. Replace the total time of d over 42 hours in our original equation for average speed. That gives us an equation of average speed equals the total distance, which we can again put in as d miles as the numerator, divided by a total time, which we now know is d divided by 42 hours as the denominator. Because total distance is in miles in our original equation, but we canceled it out in the process of arriving at our total time value, in this case, the d variable cancels out and the unit remains. So we're left with the answer 42 miles per hour.